Welcome to General Structures, Lesson 3, Example number 2, Part 2. And if you want to see Part 1, go back and see the other video. But where we left off, we were trying to first figure out what are all these angles to all these, and what are the lengths. And I said that's important because when you actually go out there and design this thing, you'll want to know what those are. But you could possibly not need those, because if you have these 13 and you have that 5, you could possibly do that without doing what I'm doing. But anyways, we're going to go ahead and do this because this is what I would do, or I design the thing. Alright, so we left it off right here. We knew what this angle was. Now we need to figure out what this angle is. Right here. And that's pretty simple. Let's take the 180 degrees of a straight line minus 2 times 26.5, what? 26.57. And then let's subtract that 67.38. And you get 59.48 degrees for both this side and that. And this is 59.48 degrees. And then, what don't we know? We do not know this distance right here. That is the only distance we do not know. And we did not figure that out, so we can easily, by doing the Pythagorean theorem, we can go 6.6666. I'm just going to do a lot of sixes. It'll be close enough. Squared plus 10 squared equals 144.4 repeating, and the square root of that is 12.02, let's say. So this is 12.02 foot. And realistically, this would be all drawn a lot larger, and so you could actually easily see what's going on. I know this is not the easiest thing to look at here. But nonetheless, we have all of our angles, we have all of our dimensions, and that's what we're going for. I'm not going to repeat these. All these are equal. This is symmetrical about that center line right there. So when you're looking at the method of sections, what you want to do is cut a straight, or pretty much a straight line. Doesn't have to be a straight line, but it needs to be a continuous straight line through this this truss. And when you do that, you want to figure out what is the best place to cut it. Now keep in mind we're looking for 2, 3, and 3, 4, which is also BC and CD. So we're looking for this member right here and this member right there. And you can't really cut it. You'll want to cut through 3 of these, either right there, right here, or right here. I don't think it'll do any good to help cut it right here. That'd be the same as doing method of joints. So I don't think there's really one place you can cut it. You're probably going to have to make 2 cuts. You're going to have to make a cut. Let's see which is a good color to use. Let's do this in weird gray color. Do a cut right here and right here. So let's go ahead and do that. Let's get the ball rolling. And what you're looking at, actually we haven't even done reactions, have we? Wow, all this work, so little payoff so far. Let's get rid of those for right now. Alright, let's figure out the reactions, and let's do the sum of the moments. Hopefully you're at a point where you realize the first thing you want to do is sum the moments about one of your reaction points. So we're going to sum the moments about point A equals 0 equals, start from the left, go to right, 3 times 0 equals 0, or 1 times 0 equals 0. We don't need to put that. 5 times, we know that it is 10 foot. So we're going to say 5 kips. We said that's positive, so we will leave it as positive, times 10 foot. And then we add 5 foot times 20 foot, 5 kips times 20 foot. And then we add 5 kips times 30 foot. And then we want to add 3 kips times 40 foot. And then finish off with add a negative R2 times 40 foot as well. And we want to go back through this and say 5 times 10 plus 5 times 20 plus 5 times 30 plus 3 times 40 divided by 40, and you get 10.5 kips. And since this is negative, it's hard to see negative. I did it right there, but it looks like it's part of R. I'll just do it out there so you can see it. It will go on the other side, and it will become positive, and therefore it's going to be positive. So this equals 10.5 kips, and the direction that we assumed is correct. And we know that this is going to be symmetrical. The loading is symmetrical. Therefore, this will be 10.5 kips as well. All right, the reactions were easy on that one. Dunsky. Let us move on to cutting it. And let's cut it two places. One, we'll cut it right here, and that we'll be able to isolate some, and one we'll cut it right here. So let's do that first cut for originally, and let's cut it right there. I'm going to draw the diagram in, which we don't need to do that. And this is what I'll draw. Is I actually drew that, and you can see that's a slightly smaller angle. It's almost 90 degrees, so I'll just try to draw it like 90 degrees and be fine with it. Alright, and then we cut that actually. So this is and this is how I like to draw it, like this. And then I like to come in, and I'm going to change the color so you can see what I'm doing. Just go in and put a point where they're supposed to actually go ahead and where they're supposed to hit. So we'll say right there is D, and right here is C, and this is A, and this is B. Alright, and now let's go in and put our external loads on and our reactions. 5 kips, we know 3 kips, what else do we know? And we know 10.5 kips. So before, we would actually have to cut it like right here, and we do the method of joints. We'd figure out that, we'd figure out AB, AC, and then we'd move on and we go to next joint, which that might be easier for you. Sometimes you have to cut it so many times with this method of sections where you might as well just do method of joints. And in the end, in my opinion, you're going to have to know, if you're doing a normal design, you're going to have to know every single section anyway, so just do method of sections. On second thought, if you're doing it anyways, you're probably doing it on a computer program like RISA 3D or something like that, so you might not have to do it by hand at all. But anyways, that's off the point. What we want to do is we want to figure out what are, let's go ahead and put this on there. This is FAC, this is FBC, which is what we were looking for, and this is going to be, we're going to assume they're all positive, and end tension, FBD. And what we want to do is we want to isolate our answer that we want. The answer that we want is FBC. So how do we do that? Well, you can do that by making FBD, our other unknowns, 0. How can you do that? By summing the points about, or summing the moments about point A. And the reason that we'll do that, because these are concurrent. See, it goes through that line. That also goes through the line. Therefore, the only thing that doesn't go through the line is that 5 kips. So we can make that work out, that 5 kips in the FBC. But one thing you need to remember is the moment is perpendicular. So it's actually this. It's not this distance. You know what I mean? It's not that distance is not going to be your distance. It's going to be 10 foot for that 5 kips. And when you're starting out, I can see how that could be confusing, but just think about it. I don't know. What would be a good way to think about that? Anyways, just memorize it for right now. I'll do some videos on it later, hopefully give you a little bit more intuition. But right now, this is 10 foot to get to that 5 kips. And then we have to figure out what the component is for this FBC. And there's a few different ways you can go about coming up with these components. So I'm going to get rid of this box. Probably should have done that right after I made it. But anyways, there's a few different things. So you could say, well, I want to figure out, and this would be the harder way, and this is why I said you can do this without figuring out all these angles and going through that mess. But you could say, okay, well, this is oh so slightly, this is not a right angle. So I could figure out what is the right angle and come up with that and come up with that distance, because I know it's 11.8, and you could make that, and then you have it ever so slightly, you know, something like this, where it's very, very small since it's barely less than that angle. I don't know which way that would go. But an easier way to do this, that is the same moment as, let me erase this again. An easier way to do that, let's call it what it is, it's a lot easier, is to break this FBC component. So there's your FBC component. I'm just going to get rid of this FBC right here. It's getting in my way. Into this component. So this is FBCX, FBCY. As you can see, this and it would actually be more appropriate to show it down here, where you could take it at the joint, or you could say almost maybe not at the joint, but infinitesimally small point away from the joint, so it's theoretically at the joint. So it would be more right here and right here as your components, and therefore this is perpendicular, and that is concurrent with A. You could do that, or you could even take up here, you could take, and that's why I said this would be the harder way to do it. This would be the easiest, doing it down there, and that's kind of what I have shown here. I don't know if have showed is a word. Anyways, you could do perpendicular this way, but then you would also have a slight component that way. So you could do it at that joint. You could do it, you could take the components realistically anywhere along this member right here. I'm just letting you know that the easiest place to do it is at this point right here, because it actually, that's the easiest way, and that way you wouldn't even have to figure out these angles, because if you'll notice, you already know this distance that it's perpendicular to it. That's 13.4, and you'd be good. So let's continue on here. And then we have what? So remember, this FBCX is actually right down here. Let's just go ahead and put it down there, FBCX. Let's get rid of it up there, because if it's up there, it's perpendicular to, I didn't write with anything there. But if you represent it up there, it might confuse you. You could say, oh well, how far away from that is it perpendicular? So we have a moment arm. But that's not what we want to do. We want to look at it as if it's down here, because that makes our calculations a heck of a lot more easy. Alright, so continuing on, we had what? 5 times 10, and then we're going to have plus FBCY times what? 13.33 foot. And then FBD is congruent, FBCX is congruent, so we are good to go. And then we go ahead and solve for FBCY, and you're going to see that's going to be a negative value, but let's go ahead and do it. So we'll have 50 here, and divided by, and then we have to have negative, so FBCY equals a negative 50 foot kips divided by 13.33 foot. Alright, and let's see what we come up with. 50 divided by 13 point, I'm going to put a lot of 3's in there. 3.75. and that's going to be kips.